Trigonometry, Part 1, Right Triangle Trig. Today we're starting talking about trig, specifically right triangle trig. Now, y'all should recognize this as something you've seen before, but let's start off talking about the basic concept of trig ratios. All right, so we have the sine of some angle equals the ratio of the opposite side over hypotenuse. Cosine of some angle equals adjacent over hypotenuse. And the last one is the tangent of some angle equals opposite over adjacent. Now, there's a few mnemonic devices that you can use, SOHCAHTOA or anything like that. If you want to know some funny ones, Google funny sine, cosine, tangent, mnemonic devices. But this is what we're going to be using for the extent of what we're doing. So now let's look at how these ratios actually are used for a triangle. So let's say this is my first right triangle. I know it's a right triangle because I marked it as a right triangle. And then I have the side A, the side B, and the side C. All right. If this angle down here is angle theta, meaning that's the angle that I want to know, all of my trig ratios are based off of this angle if this is the angle I'm using. If I was using this angle, then it'd be based off of that one. But we're doing it off of this one. So let's start off with sine. So we know that sine is opposite over hypotenuse. So if I look at this, my box, if I were to make an arrow coming out of the box, it points to the hypotenuse. So C is my hypotenuse. It's the opposite of my 90 degrees. All right. The side that does not touch the angle I'm looking for. So if I look at it, this theta is made up of B and C. That means its opposite side is A, because A does not make up the angle. All right, so when I do sine, it's opposite, which is A, over hypotenuse, which is C. So the sine of theta is opposite A over hypotenuse C. If I do the cosine of theta, now instead of using the opposite, we now use the adjacent. So this angle is made up of C and B. C is the hypotenuse, so that makes B the adjacent side, because the adjacent side is the side that makes up the angle, but isn't the hypotenuse. So adjacent over hypotenuse. And the last one is tangent, which is opposite over adjacent. So opposite over adjacent. You can also think of it as opposite over adjacent. So A over B. Here is my next triangle. I'm going to make this angle theta. Now, notice that this time I am giving my sides values, 3, 4, and 5. I'm still going to do the same type of trig ratio, okay? So in this case, this is my theta. So the one opposite of my 90 degrees is my hypotenuse. So I'm going to put a little H there so I remember it. The other side that makes up my angle is the adjacent. So I'll put a adjacent, which means that this one over here is my opposite. All right. So when I do sine of theta, it's opposite over hypotenuse. So 4 over 5. Now, does 4 over 5 reduce? No. Then that means we're done. Now I do the cosine of theta. So adjacent, which we said was 3 over hypotenuse, which is 5. And the last one we're looking at is tangent. So the tangent of theta will be opposite over adjacent, 4 over 3. So opposite and adjacent is relative to which angle we are looking for. Now we're gonna do some trig where we're actually trying to find a missing side. So if I take this triangle, this is my 90-degree angle, right? I'm told that this angle is 30 degrees and this side is 15. Now in this case, we're looking for the two sides, X and Y, all right? So I can use trig to find my missing sides. Now notice that if I'm using the angle 30, then 15 is the adjacent side to 30 because Y is my hypotenuse, which means that X is my opposite. So I'm just doing marks so I can set up my trig ratios. Now, I'm gonna plug in for 30 for the measurement of the angle and 15 for the adjacent side when I'm trying to solve. So first we need to figure out which one we want to solve for. If I want to solve for X first, notice X is the opposite side of 30 degrees and 15 is the adjacent side. I have to use the 30 degrees and 15 at the same time if I want to be able to solve for the third missing piece. So if I'm using opposite and adjacent, that means I have to use tangent. So I can set it up as the tangent of 30 degrees equals opposite, which is X, over 15. Now, to solve for X right here, I would multiply both sides by 15. And so I have 15 times the tangent of 30 equals X. Now, I would put this in the calculator, and I would find out that this is 8.66. X is 8.66. Now I'm going to do the same thing for Y, but I'm going to use the trig function, which uses Y. I could use the 8.66, but it wouldn't be as accurate since I did round to the second decimal place. But I'm going to use the 15. So I need to use the trig function that uses adjacent and hypotenuse. So that means we're using cosine. So the cosine of 30 degrees equals adjacent over hypotenuse. Now, since the thing I'm looking for is on the bottom of the fraction, I'm going to take the cosine of 30 and the Y and switch their places. So now I have Y equals 15 divided by the cosine of 30. All right, so when I do Y equals 15 times divided by the cosine of 30, I find out that Y is 17.32. All right, so there's my value for Y, and we just saw my value for X, which was 8.66. Now for this one, we're gonna do the same basic principles. I have an angle and a side, so I'm gonna use my trig functions to find a missing side. I could go ahead and find this angle since the interior angles of a triangle add up to be 180. I know that this one would also have to be 40 degrees. And then I could do whichever trig function I wanted to, but I'm gonna base them off the 50. All right, so since I have the hypotenuse is 21, I'm gonna use either sine for the X or cosine for the Y. It doesn't matter which one you do first, but I'm gonna do sine. So the sine of 50 equals opposite, which is X, over hypotenuse, which is 21. So when I solve this, I multiply both sides by 21, and that gives me 21 times the sine of 50 equals X, which I find out that that is equal to 16.09. I typed this in the calculator just the way it looks, 16.09. Now, we're in degrees. I didn't say this, but if we're dealing with degrees, you need to make sure that your calculator or Desmos is in degrees. If it's in radians, which we'll get to later, it'll tell you something completely different. All right, so now we're gonna find Y. So Y is my adjacent side. It's the one that is part of the angle that makes up 50 degrees. So I'm gonna use cosine. Cosine of 50 degrees equals adjacent over hypotenuse. So once again, I multiply both sides by 21, and that gives me 21 times the cosine of 50 degrees equals y, which I find out that is equal to 13.50. There's two types of people in this world. Those that can't extrapolate from incomplete data. Now we're going to look at what happens when we're trying to find a missing angle. So we're still going to set it up using the same concept. The thing we're looking for this time is an angle, and I'm giving two sides. As long as I either have both sides or an angle and a side, I can find the third missing piece. Now, when I'm doing the trig for a missing angle, we're actually going to do what's referred to as inverse sine, cosine, and tangent. On a calculator or a Desmos, inverse sine, inverse cosine, and inverse tangent all have their button, all right? You hit second sine, second cosine, second tangent if you're on the calculator, and then you just click on the inverse ones if you're using Desmos. So it doesn't matter which letter I use. I can use either one. If I use the y, it would be opposite over hypotenuse. If I use the x, it's adjacent over hypotenuse. So it doesn't matter which one. I'm going to use the x, all right? So I'm going to use cosine. So the cosine of the angle, which is x, equals the ratio of adjacent over hypotenuse. Now, the x is inside the cosine. When we use the inverse cosine, that is what allows us to find x. So when we take the inverse cosine, we switch the x and its ratio. And so now the inverse cosine of 12 over 20 will tell me what angle gives me this triangle. All right, so when I type in inverse cosine of 12 over 20, here's another problem, same idea. I'm trying to find the two missing angles. Now in this case, notice that I don't have my hypotenuse. So that means I only have one option, tangent. It doesn't matter which one, I'm gonna use tangent, but it's gonna change the ratio. If I do x, it's gonna be opposite over adjacent, so 38 over 23. If I use the y, it'll be opposite over adjacent, which is 23 over 38. So it doesn't matter which one you pick. I'm gonna do the y this time. So the tangent of y equals opposite, which is 23, over adjacent, which is 38. Now, so since I'm trying to solve for y, and y is inside of the trig function, I'm going to use the inverse tangent of the ratio to find the angle. So when I do the inverse tangent, I found out that y is equal to 58.82. So y equals that. So to find x, once again, x and y together have to equal 90. So I can say that x equals 90 minus 58.82. All right, 90 minus 58.82 is 31.18. All right, so there's x, there's y. I have found my two missing angles.